everybody. This is section 3.3 for Math 211 from our geometry textbook. I made mention in section 3.3 that we're going to look at a bunch of theorems, and then in the next section we will look at the converse, and that's what we're going to do. So we started off with the alternate interior angles theorem in 3.2 where we were proving lines were parallel. But now the converse, remember, that switches P and Q in your conditional statement. Now for the converse, the theorem says if two parallel lines are cut by a transversal. So now, excuse me, the given information is that we have parallel lines. So now we're looking at the angle relationship. So if we have two parallel lines cut by a transversal, then alternate interior angles are going to be congruent. So for instance here, 4 and 6, because the lines are parallel cut by a transversal, they are congruent. And then also the pair of 3 and 5 are congruent. Okay, so now they have given us two parallel lines cut by a transversal. And we know that angle 3 is 55 degrees. So I'm going to write that in there. Oops, that's not very good, but it's 55 degrees. And what they want us to do is to find the other angle measures. So if we have one angle measure, we can find all of the other ones. So I want you to think back about what you know about angles and angle relationships. And pause the video for a second, see if you can name the other 7 angles, and then come back and we'll go through it. And just know that when we do go through it, my answers may not be exactly the same as yours, but yours still can be right. The measurement won't change, but maybe the reasoning that you used will change. Okay, so hopefully you pause the video and you're back to check now. When I look at this, I'm going to start and just think of simple stuff we learned in chapters 1 and 2. And I know that angles 3 and angle 1 are vertical angles. So that means that the measure of angle 1 is going to be 55 degrees because it is vertical to angle 3. All right, now I also know that we have, our transversal is a straight line, which I can't draw a straight line apparently. But then I also know we've got linear pairs here. So I know that angle 2 and angle 3, or angle 1 and angle 4, are going to form a linear pair, which means they equal 180. So if I take and I do 180 minus my 55, that is going to give me 125 degrees. So angle 2 is 125, and then through the linear pair with 3, but also 2 and 4 are vertical, so angle 4 is 125 degrees. Now, we have to go to the other side and look at the other angles. This is where, knowing that we have parallel lines cut by transversal, we also know that alternate interior angles are congruent. So 3 and 5 are a pair of alternate interior angles. So that means that angle 5 is going to be 55 degrees. And then once we go from there, if we know that 5 is 55, again, we can just start looking at vertical angle pairs. So if 5 is 55 through alternate interior angles theorem converse, then 7 is also 55. And we can just say, because it is vertical to angle 5, we can also, again, use the interior angles theorem converse, because if 2 is 125, then 8 is an alternate interior angle to that. So the measure of angle 8 is going to be 125 degrees as well. And 8 is vertical to 125 or to 6, so that's 125 as well. And again, sometimes you may have said, well, I know that 5 and 6 make a linear pair, so your reasoning may have been a little bit different. There's lots of different ways to explain your answer, which is kind of what I like about geometry. It's making you look at all different ways, not just one single answer. All right, our next theorem is the corresponding angles theorem converse. And this theorem says, again, we're starting with parallel lines. So if two parallel lines are cut by a transversal, then corresponding angles are congruent. So not only are alternate interior angles congruent, but also corresponding angles. So remember, corresponding angles correspond to the same position. So that means like angle, if I were to cut this down the middle of that transversal between the two parallel lines, and I were to lay these 4 angles on top of these 4, 1 and 5 are a pair of corresponding angles, so they have the same measure. 4 and 8 are in the same position, so again, they have the same measure. 2 and 6 would have the same measure, and then 3 and 7. Our next theorem is the same side interior or consecutive angles theorem converse. And again, we're going to start off. If two parallel lines are cut by a transversal, then same side interior angles are supplementary. So that, remember, means that any angles that are on the same side of that transversal, like 4 and 5, they are not congruent, but they are supplementary. So they add to 180. The same goes for 3 and 6. They are same side interior angles that would add to 180. All right, our next theorem that we're going to look at, and our final one for this section, is going to be the alternate exterior angles theorem converse. And this theorem says if two parallel lines are cut by a transversal, so it starts off the same way, then alternate exterior angles are congruent. So that means, 1 and 7 are a pair of alternate exterior angles, so they are congruent. And then also we have 2 and 8, a pair of alternate exterior angles, so they are congruent as well. Okay, so now we're going to find missing angle measures again. And this is going to be similar to the problem we did earlier. So they told us that the measure of angle 4 is 42 degrees. I'm going to put my 42 in there. They want us to find the measures of the other angles. So again, remember, you can start off by just using vertical angles. 4 and 2 are vertical angles. So that means that the measure of angle 2 is going to be 42 degrees as well. And then we can also look at, now that we know our theorems, we can look at corresponding angles. So 4, I'm going to erase the 42 so we can see it. I know that 4 is in the lower left-hand corner, and so is 8. So that means that the measure of angle 8, because they're corresponding angles, would also be 42 degrees. 8 is vertical to 6, so that means that the measure of angle 6 is 42 degrees. And now we got to find the angles. We're going to do the measure of angle 1, the measure of angle 3, the measure of angle 5, and the measure of angle 7, our left. Now I do know that 4 and 3 form a linear pair, which means they add up to 180. So if I do 180 minus 42, that means that I am going to have the angle measure for angle 3 to be 138. Okay, and then we know that 3 and 7 are corresponding, so that's going to equal 138 because they're corresponding, they're in the same spots. And then also think vertical angles. 3 is vertical to angle 1, so it's going to be 138 degrees. And the measure of angle 5 is vertical to 7, so it will also be 138 degrees. So if you have parallel lines cut by transversal and you know one angle measure, you can easily find the other 7. Okay, so now we are using the figure shown. We want to know the measures of angle 3 and angle 4 and which theorem justifies our answer. So if we take a look here, here is angle 3 and here is angle 4. From the information given, I know that L is parallel to M and P is parallel to Q. So let's start with angle 3. If I look at M as not as a parallel line, but as a transversal, because I see that this angle, the 105 angle, is connected to this line M, and so is 3. So that makes these two angles, angle 3 and the 105 angle, alternate interior angles. Because they are alternate interior angles, that means that the measure of angle 3 has to be 105 degrees. And again, it would be our alternate interior angles theorem converse. It's a mouthful, but that's what it would be, the converse, not the theorem, but the converse. Okay, now I think we're going to have to use some of that information to help us find other angle measures. I do know, because 3 is 105, that now 5 is 105 because of vertical angles. And I need to kind of find the measures for the angles over here. It's a different transversal. But I know 2 and 5, if I look at P as my transversal, are going to be in same side interior angles. So that means they're supplementary. So if they add to 180, so if 5 is 105, then angle 2 has to be 75 degrees because that gives us 180. So if angle 2 is 75, and then if we look here, if this is my transversal, if I treat L as my transversal, and I know, so here's my transversal now. If 2 is 75, 2 and 4 are in corresponding spots. They're in the same spot. So that means that the measure of angle 2, if it's 75 degrees, and it corresponds to angle 4, then the measure of angle 4, is 75 degrees. And I'm going to say my theorem that I use would be the corresponding angles theorem converse. Okay, and the last question that they're going to give us for section 3.3 is we need to find the value of x. Now, when I look at my two angles, or I look at my picture, just to find information that I know that angles x plus 30 and 3, they are a linear pair. But I don't know anything about 3, so it's hard to find that angle measure. However, because I do have parallel lines here, these are parallel lines, and this is my transversal, I know that 3 and this 105 here, notice they're alternate exterior angles. So that means those two angles are congruent because they're alternate exterior angles. So that means that 3 equals 105. And to find x, if 3 and x plus 30 are supplementary, I'm going to do x plus 30 plus 105, and it should equal 180. I'll simplify it, so x plus 30 plus 105 would be 135 equals 180. Then I'll subtract 135 from both sides, and I end up with x equals 45. So that would be the value of x. It's all about looking at those angle relationships. How are the angles related? Can you find other angles that you know are either corresponding or alternate interior, alternate exterior? Look for those relationships and figure out what the angles equal.